and welcome back to my channel, and also welcome back to the set series in my channel. This is part 2, operations of sets. If you haven't watched part 1 yet, I would really recommend that you watch it before you watch this, because maybe you might have no idea what you're seeing and why. So I really recommend that first. But if you're along for the journey, then we can dive in. But before we do that, I want you to hit that like button, hit the subscribe button, and ring the notification bell for more amazing videos like this. And then I'll see you in another one, and we can learn more. So, without further ado, let's begin. Union and intersection. The union of two sets is when you take two sets and you list all their elements with no element repeated. For example, if A is equal to 3, 9, 2, 4, 6 and B is equal to 3, 5, 7, 2, 8, 6, then A union B is equal to 2, 3, 5, 6, 7, 8, 9. This is basically the terms that we got in order, and if you see in A and B, 3 is repeated, but we don't put 3 2 times, we only put 3 once. Because we don't repeat in the union, we only just take the common terms, which is 2, 3, 5, 6, 7, 8, 9. The symbol for a union is a U here. Meanwhile, the intersection of two sets is when you list down the common elements of the two sets. For example, we take the same two sets, A and B here, but the A intersection B is 2, 3, 6. This is because you can see 2 is common, 3 is common, 6 is common, nothing else is common. So you can say A intersection B is equal to 2, 3, 6. Again, you can't repeat anything in any way, though I don't see how you can repeat it in an intersection. So, and the symbol for intersection is an upside down U. So you can say like the union upside down. And union and intersection are technically opposite, so it makes sense. So you can remember it like that. The universal set. The universal set is the set with all possible values that are possible to go in the set. And those numbers are considered as the real numbers. Now the real numbers are their decimals, their fractions, they're also normal numbers as well. There's basically almost all of them. It's one step higher from rational numbers. So we still don't have imaginary numbers of the sort. You're not allowed to have like irrational numbers. You're not allowed to have those. Just real numbers. Any other numbers that are irrational or imaginary considered not to be inside the universal set. Also, it's important to remember that the universal set can depend on the question. For example, if A is equal to 1, 2, 3 and B is 4, 5, 6, then the U, which normally stands for universal, is equal to 1, 2, 3, 4, 5, 6. U represents the universal set. Now, the thing is, the universal set is a set with all real numbers, but also sometimes they're talking about the universal set depending on a question. So basically, you just have to write all the terms again. So, here. Complement sets and their properties. To find a pair of complementary sets, the pair must follow these 4 properties. If we have a set P, then the other set, P dash, will have all the elements in the universal set except for the elements in P. For example, if P is equal to 1, 2, 3, then P dash is equal to 4, 5, 6, 7, 8. But this also means that P, the union of P and P dash, is the universal set. There is no intersection between a set and its complement. For example, if P is 1, 2, 3 and we said P dash is 4, 5, 6, 7, 8. So the complement set is basically all the elements that are inside the universal set but are not being common with P. Like here, this is basically all the real numbers inside here. We haven't written like all the numbers yet. We're just writing it just to show that this is all the numbers in the universal set except for 1, 2, and 3. So this is why we can also say that since there are no common elements, P intersection P dash will be a null set. As we said from last episode, a null set is basically a set with no elements, where elements are the values inside a set. 3. The law of double complement. If a set P has a double complement, then that set would be equal to P. Since, we said P is 1, 2, 3, P dash is 4, 5, 6, 7, and so on. But what if we would have a complement to that P dash? That's the law of double complement. Okay, so let's take the set of P dash and imagine that it's P. What was the complement? What would that new P dash be? It would be 1, 2, 3 because all the elements in the universal set are going to be taken away. Only thing left, 1, 2, and 3. So P double dash is equal to, you would say double dash P dash dash. So it's P dash dash is equal to 1, 2, 3. So P dash dash is equal to P. It's that simple. So 4. If a set P is an empty set, also called phi, like here is the phi symbol I was talking about. A phi normally represents an empty set or a null set. They're the same thing. So phi. Then P dash will be the universal set. If a set P is an empty set, then P dash will be the universal set. For example, if P is empty set, we see here, then P dash is 1, 2, 3, 4, 5, 6 all the way. And that will definitely be a universal set because you have no elements in P. So all the elements would be included in P dash. It goes vice versa. If we took U, 1, 2, 3, 4, then U dash would be an empty set or phi. Remember, it'll not always be P. I'm just taking P here for the example. It could be H dash and H, R dash and R. It could be any symbol or value. So basically, here it says F dash is equal to U and F phi dash is equal to U and phi is equal to U dash. Ordered pairs. A pair of elements that occur in a particular order and are enclosed in a particular bracket are considered ordered pairs. To simplify what I just said right now, let's say that we have two sets. Like here, we have two sets. A is 1, 2, 3, 4, B is A, B, C, D. The thing is, we want to put them in order in a way like in pairs, like in pair sets. So we take the first terms of A and B, 1, A, and we enclose them in brackets to make an ordered pair. We do the same for the second, then the third, then the fourth. You can then say that the ordered pairs are X is equal to 1, A, 2, B, 3, C, 4, D. So basically, the properties here are that the ordered pairs are closed in a bracket, and the ordered pairs themselves also have brackets, so that works. And also, there's a pattern. The first term first, then the second term, then the third term, then the fourth term. So that's what ordered pairs basically are. The Cartesian product. The Cartesian products, when you take two sets like this, we had A and B from before, 1, 2, 3, 4, and A, B, C, D. And then you make ordered pairs, as we said before, by taking the first term of set A, then pairing it by all the elements of set B, and doing the same with the second, third, and fourth element of set A. For this example, we could say A times B is equal to 1, A, 1, B, 1, C, 1, D, 2, A, 2, B, 2, C, 2, D, 3, A, 3, B, 3, C, 3, D, 4, A, 4, B, 4, C, and 4, D. Oh, and don't forget the bracket there at the end. It's not here in this case, by mistake. And basically, if this sounds confusing to you, we did the same thing with ordered pairs, but instead of only the first term, we do the first term with all the terms in B. We take the first term in A, put them with all of the terms in B. Same with 2, all the terms. 3, all the terms. 4, all the terms. And then you get this big one, big set. So ordered pairs can be written in any way. You can find a lot of ordered pairs. But this is basically one way. They're ordered, so it's ordered pairs. And that's basically what the Cartesian product is. So you always do this when you say A times B. It's basically multiplication with sets. Because it works also in algebra. If you studied algebra before, you can relate to this. We can also write the Cartesian product in the builder form of the set, like a generalized form. So the builder form, if you haven't watched the first episode, as we said, is a set, but instead of the elements, we write the properties of the set. You might want to go back to the first episode if you don't remember. Now, A times B is equal to A comma B colon. So you're describing the ordered pairs. The first one is A comma B. A belongs to A, B belongs to B. That's it. Basically, it's saying we take one element from A, one element from B. They're A and B, and we just have to state A belongs to A and B belongs to B. That's it. But the A comma B shows how the elements are put into ordered pairs, and the A belongs to A it shows that the element A belongs to set A. The same thing is shown with B belongs to B, showing that the element B is an element of set B. The difference of sets. To calculate the difference of two sets, you take the first set. We'll call it A, and take out all the common elements that are also there in set B. So basically, you take out all the elements that are intersecting. The remaining elements that are in set B, if there are any, will also be taken away since we're only focusing on set A here. Here's an example. So, if A is equal to 4793 and B is equal to 1324, then A minus B is equal to 7, 9. Basically, the thing is, 4 and 3, the intersection, we take that away. You can call it intersection, whatever you want, but I'll just call it common elements to take it away, the confusion, if there is any. So you take away the 4 and the 3 from both sets. And then you also take away the 1 and the 2 because we're focusing on A here. The A set is first. And then the 1 and the 2 will go away. So you just have A minus B is equal to 7, 9. The difference can also be B minus A or Y minus Z, depending on whatever the set is. So you can remember that you must focus on the set that is the first term shown in the X minus Y. X and Y are just the pretend sets here. We're just saying like a generalized form for that. In this case, it was A, but it could be anything else later. 6 equations of sets. Now, okay, I'll give you some time to try and read them out if you've seen them, since we've seen them before. And you can pause the video. I'll give you 5 seconds on the video itself because basically you'll be pausing the video and you'll have a lot of time. So 5, 4, 3, 2, 1. Okay, we're gonna go for the equation 1 here. The number n is a number. If you haven't seen it in the first episode, you can go and look at it. N normally means the number. So the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. Now with these types, there's actually like a type for equation 1. Number 1. You can like directly find the formula to this without asking for it. Because it depends on here. Like here you have NA union B is equal to NA plus NB minus NA intersection B. It basically means that N, the number of elements in A plus the number of elements in B minus number of elements in A intersection B. It gets increasingly bigger with a pattern. If you add in more sets, and I'll show you that later in the last equation, but that'll be for intersection here. So now for 2. Let's see if you read this correct. If A union B is equal to phi, that means it's an empty set. So that if there is if A union B is equal to phi, then the NA union B is equal to NA plus NB. Okay, sorry, that was a mix-up. You might also get confused if you've seen before. If A intersection B is equal to phi, I think it meant. But you can also check down the comments below and see. And then we go 3. NA minus B plus NA intersection B is equal to NA. Now I can explain this. This is because when we take the difference, we only take the elements of set A which aren't common with B. And then we take the elements that are common in set A with set B. Which means that you add the amount. When you add the amounts, you get the number of elements in set A. Basically, you take the elements of set A that aren't common with B, then you take the ones that are common. So altogether, that'll be all the elements in A, right? So that's the thing. Also, it means A intersection B is equal to phi. Sorry for that typo. And the reason is that now you have no n number of elements in the intersection. It's basically the same thing as NA union B. But the thing is, now the NA intersection B is 0. So you could add a minus 0 there for a bit more clarity, but that's the thing. So just remember that's A intersection B is equal to phi. Sorry. Now, 4. With the same logic used before, you can say this. The number of elements in B minus A plus the number of elements in A intersection B is equal to B. We said that before. And also, I'll give you some time to do it for 5. And 5, 4, 3, 2, 1. So you were supposed to read it, or if you didn't understand what I meant, you were supposed to read it. And then 5 is NA minus B plus NA intersection B plus NB minus A is equal to NA union B. Now it's also the same logic that this is written, because the number of elements that are only there for A added by the number of elements that are only there for B plus the common elements would be equal to every element, which is the union of the two sets. So you're taking the elements that are not common in A, elements that are not common in B. So basically the common thing is left, then you get all the elements. That's NA intersection B. And you're done. You get NA union B, which is always all the elements. And also, just another thing for a property 4, that is basically NA minus B, but backwards. So remember that. Now, 6. This is what I was saying for the pattern. Here we have an intersection, and this may look complicated, but it's using logic from Venn diagrams, which are basically sets but geometrically shown. You might have heard of them before. So note that it's better to use these formulae when you have a small amount of sets and information. Otherwise, you can use Venn diagrams and you can instantly find the answer. So only when you have small amounts. Here, this is if you have 3 sets. Now, try and read this out. I'll give you some time to pause the video. In 5, 4, 3, 2, 1. Okay, let's see if you got it correct. So the number of elements in A intersection B intersection C is equal to number of elements in A plus the number of elements in B plus the number of elements in C minus number of elements in A intersection B minus the number of elements in A intersection C minus the number of elements in B intersection C plus the number of elements in A intersection B intersection C. This may look complicated, but the really funny thing is that NA, NB, NC, and all that, except for the NA intersection B intersection C. They're exactly the same thing on the left side and right hand side. The last term on the right hand side and the NA intersection B intersection C, they're the same thing. So basically, the rest is equal to 0. That's also really nice, But anyways, there's like a pattern to this. First, you have plus, 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 like pluses and pluses when you only have one set. We're talking about the amount of elements in A, B, and C. And then you minus that by the number of elements in A union B, A union C, and B union C. So if you would like to imagine like a Venn diagram of free circles, you might have seen it before. Like one is at the top and the two are on the bottom. Each pair of circles has a common area, and they all have one common area in the middle. Now basically, take all free circles. Now we can say that you basically took too much, because you also included the common area more than once, definitely. So you take away those common areas as well. And now basically what we do is that at the end, you also, while you were minusing A union A intersection B, A intersection C, and B intersection C, you took away the middle part. So you have to add the middle part again. Then you take NA union B NA intersection B intersection C. Sorry if I might have said union. Sorry. So the thing is, with an increase of the amount of sets, you also change the sign. It goes from plus plus, then you go to 2, it's minus minus minus, then you go to the amount of free, it's plus. And you also have to do all possible combinations until you get to the final part. So, thank you for watching this episode. I'll see you in another one, the properties of sets. It's going to be coming out tomorrow, very soon. So please like, subscribe, ring that notification bell so you know when it comes and we can learn more together. And I really enjoyed teaching this to you so far, so I really want to see you in the next episode. So I'll see you there. Just hit that subscribe button and ring the notification bell. And goodbye!